Hello, STEM Nation. Jeff here, and welcome to episode number 77 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share it with a friend. Now let's get fired up today with our guest, Stephanie, and I hope our chat will help ignite your passion towards a STEM career. Stephanie earned a bachelor's degree in chemical engineering with a focus on nanotechnology and a master's in electrical engineering with a focus on green technologies, all from the University of Southern California. Welcome to the show, Stephanie. Fill in any gaps and share a bit of your personal life.
Sure. Hi, Jeff, and hi, everyone else. I am now working at Intel as a yield analysis engineer. Right before that, I was an environmental process engineer. I live in Portland, Oregon. In my free time, my husband and I travel and we sail.
So, Stephanie, let's dig right in here. So you've got a chemical engineering degree, which is interesting because you also went on to get an electrical engineering degree. Can you go into how you're able to go from chemical engineering into electrical engineering?
Yeah, sure. It's funny people ask me this question. It's actually quite natural for me. It all kind of started just based on the question of what I wanted to do as a career, but I guess I'll start from the very beginning. I was attracted to chemical engineering in the first place because it's a very broad subject. Many industries hire chemical engineers. When I started in college, I didn't really know what I wanted to do or which industry I wanted to go in, so I thought, no, with me being pretty good in math and chemistry, it's a natural choice. Halfway into college, I got more exposure into what kind of topics that really attracted me, and specifically, it was renewable energies. So I signed up for my research, which became my master's, and it's in the topic of solar cells, and that's an electrical engineering subject, I guess. So I guess the transition kind of happened because I want to continue more learning just how power electronic devices work. And that's how I decided to pursue an electrical engineering master degree instead of just continuing on learning more about chemical engineering, because I believe that just having that diversity helped me just explore more into the area that I want to turn into a career.
All right, thanks for that, Stephanie. And could you go into a little bit about what nanotechnology is?
Yeah, so it's a buzzword, I think.
Yeah, I think it
Um,
is.
yeah, my school require us to have a focus, and it's really material science. It's looking nanotechnology. It's referring to the study of molecules and material properties at nano scale, and most molecules, all of them is in that range. So we take a lot of classes, and we do experiments that really looking at just how molecules and molecule interact with each other in different applications. And that's so it covers many different real life applications, but that's in the gist of it is looking at material science at the molecular level.
Okay, and Stephanie, so you work at Intel, and think of Intel as a semiconductor company. So I naturally think of process engineers, electrical engineers, designing the silicon, designing all the tools. But you're a chemical engineer and doing yield analysis, if I understand that correctly. Could you describe to STEM Nation what that means?
Intel, like you said, everything of the above was true, but we also a very big manufacturing company. One of its really industry leadership comes from having really groundbreaking manufacturing process technologies, and that requires a lot of understanding of materials and chemical processes, and that's what chemical engineers do. So when I joined Intel, one of my first roles was to support the R&D department on the different chemicals that they're going to bring on site. And that opened kind of my exposure into just how microelectronics turn silicon, which is a major component in sand, into the microchips that we know, a very complex process. And over the years, I got very familiar with the process, and in the last couple years, I have decided that I've known enough about the chemical side of things. I wanted to kind of polish myself on more of that data analysis and kind of the visualization of really driving kind of decisions at the company. And that's when I move into this role of U analysis. U analysis is really looking at the whole manufacturing process and looking at where we are losing our efficiency in manufacturing, where can we improve and kind of drive more products out of our existing production line.
So I assume, Stephanie, that you don't work alone when you're doing this yield analysis. What other type of professions or engineering professions do you work with on a daily basis?
Yeah, no, I don't work alone. The skill sets we're looking for when it comes to U analysis is really someone that love kind of massaging data and kind of looking at trends and be able to present your findings in a very precise manner. So it really isn't a specific major that we're looking for. So in my team, we have folks that had a physics background. We have folks with electrical engineering background or material science. Each of us kind of bring in a different sets of knowledge. So I obviously, with a chemical engineering background and electrical engineering background, I come in kind of knowing more of how different chemistry behave and how they interact and drive reactions. Someone with a physics or a electronics background could come in with more understanding of, oh, how do we actually pull data out of these microelectronics devices, and what do these data actually mean in real life. We also work a lot with the process owner inside the factories. So those typically tend to be chemical engineers or material sciences. They actually own a piece of equipment inside the factory, and they are the expert of what that step does in the production process. So we do work together as a team, and we actually interact on a daily basis, multiple times a day. And the idea is, you really do need kind of this synergy of different people coming from different backgrounds to come together and actually drive decisions in a way that really move the process forward.
Yeah, and STEM Nation, just to clarify a little bit what Stephanie's talking about from a yield perspective, think of manufacturing. Anytime there's any sort of waste in the product where you have to scrap it, that's lost revenue. So when you create a semiconductor, you have a wafer that has only so many die in it. So let's say that there's 100 die on that wafer, and if 2 of those die fail during test, you have to throw those away. So if you can increase the yield, theoretically, if you get to 100%, that means that everything that you produce goes out as product, and that equates to profit and revenue for the company. And that's what Stephanie is trying to drive towards.
Yeah, exactly.
So Stephanie, let's get specific here. And what is one thing that really has you fired up today in the area of yield or chemical engineering or electrical engineering or anything in general?
I really like looking at chemistry a lot. I think it's fascinating. I think just since I was in high school and college that I find, it's not just really the chemical itself, but really when they do come together, what are the interactions between them that really drive that amazing product of you can start with one material in the beginning and then you end up with something that it's more than just all of them combine. So that process has always made me just keep coming back and doing my job and learning along the way.
So if there's some students out there that really, really like chemistry, would you recommend them to go for a chemistry degree or a chemical engineering degree?
So that's a $1 million question. So I think it really depends on whether this person is more interested in work, like the environment that they think they would thrive in. A chemist tends to work more in the lab environment. Maybe there will be research positions in certain companies that would require them to also work in like a more interfacing with academia. Versus the chemical engineers would be someone maybe that enjoy more doing hands-on equipment type and really bringing that knowledge of chemistry into something that is an application. So that's, I think, is kind of the biggest distinction. So I guess if you're into chemistry, ask yourself the question, do you see yourself working in a lab, working more proof of concept, smaller scale experiments, or do you get more excited bringing that experiment, the result of that experiment, into real life?
Thanks for that, Stephanie. And I'm going to add a little bit to that. So my understanding of chemical engineering is that it's very, very math intensive, whereas maybe a chemistry degree would not be. Is that true?
Based on the curriculum, I think that is true in most programs. But I would also say that the mathematics requirement in chemical engineering isn't isn't as rigorous as some of the other engineering disciplines like computer science or electrical engineering. So I personally really like math, so I it wasn't it wasn't it wasn't a challenge for me in school within chemical engineering. I would say some of the other some of the other classes within chemical engineering itself is more challenging. So I guess depends.
Okay. And we're going to transition here into a story. Could you take us to a moment in time where you've had an aha moment and how you maybe turn that into success?
I had a chance to do an internship over the summer of my sophomore year in college. That's my first internship, and it's my first engineering position, and I'm getting engineering salary. It was very exciting, and the aha moment came when I kind of mentioned earlier that I went into chemical engineering because I believe it gives me a lot of access to different industries. I could work in different areas, and my aha moment came when I realized that not all industries are the same, and that there are certain industry, the culture or the value or just the general way of approaching the engineering and technologies is different from the other. So after that internship, it really gives me kind of this perspective of, okay, I really need to think about what I would like to do and if I see myself fitting into that industry. And that really helped me kind of just path the next step in my education, as well as the companies that I go look for jobs after I graduate.
Yeah, so STEM Nation, listen to what Stephanie was saying there is that, after her first internship after her sophomore year, is also, it's not so much always what you're doing, but the culture of the company. So you want to try to look for things that, the culture might fit your personality as well. And what are some takeaways that you had, Stephanie, through that internship that, you said, hey, you know what, this is the type of culture that I enjoy?
hmm So that internship, it's more the opposite. I found out what I don't enjoy. The company as well as the industry that I was working for was one of the more traditional chemical engineering industry that existed decades. And their approach to technology is a little bit more conservative. It isn't what we would consider high tech. It isn't, there wasn't a lot of focus on just innovations or new ideas. It's a heavily regulated industry, so it is understandable that they do take more of a careful approach. They tend to go for things that have approaches that have already proven it's working. So after that internship, I realized there is part of me that I just really enjoy. Working on new products, coming up with new ideas, and really being able to contribute kind of this change in my daily routine. So that's how I kind of learned a little bit about myself and learned a little bit about how I wanted to approach my job in the future.
Yeah, STEM Nation. So those internships are so important during college. And like Stephanie was saying, she didn't find out things she wanted to. She found out things that she really didn't want to do, which is just as important as finding out what you do want to do. And the nice thing about the internships is they're relatively short. They're summer. If you do a co-op, maybe they're a semester and a summer. But work and drive to get that internship, gain that experience. Thanks for that, Stephanie. And in order to get those internships, in order to get one of the careers in STEM, you got to get through college. So, Stephanie, when you were 18 years old or so, heading off to college, what are some things that you wish you knew back then that you think would help STEM Nation get through college successfully?
There are a couple of things. The first one I would really encourage, just like everything you just said about the internship and co-op, really go out there and explore and really take advantage of the network that your school may have with companies, and really try out kind of the different flavors of engineering positions or STEM positions within your subject. If you and do kind of try a little bit of both within academia and industry. Try to work on a research project, maybe for a short couple months. I think professors are usually very open to have undergraduates or even graduates to kind of join their team and work on a very specific projects. You can kind of learn how, if anything, you will learn whether you want to go pursue a graduate degree after undergraduate. Learn kind of that research environment. How do you analyze a problem and tackle and come up with different hypotheses. That itself is a very valuable skill to have. And then at the same time, you can try out if you want to go into academia. At the same time, doing internships and co-op, like you say, Jeff, it's a very valuable experience, a couple months, and you kind of like get in the door and kind of really see how people interact in that company or in that industry.
Yeah, and Stephanie, going from college into a professional, either an internship or your actual career, what is one or two attributes or skills that you think are needed to be successful when you transition from college into your career?
Master time management early on. Is very important. I wish I had known. And I'm saying that not just because it's not just between work and outside work. You also want to be able to master your time with your families or time for yourself. And it's because once you start working, you're gonna get busy very quickly, and you're gonna get consumed by all the things that are no longer, that are so, I guess, perfectly scheduled or planned for you, just like in college or in high school. In adult life, you kind of have to prioritize what's important for you. So I would say master of time management early on would be a key to success.
Yeah, and Stephanie, I'm in a complete agreement with that. You have to master your time, or the time will master you, and you don't want it to work that way. And we're going to take a quick pause and thank our sponsor, Audible, who's offering a free audiobook. You could head over to STEMOnFireBook.com, that's STEMOnFireBook.com, to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep the audiobook. And it is lightning round time. Stephanie, are you ready?
Yep, I am.
What is the best piece of advice you've ever received?
Mentors others. I think in the beginning of my career, I thought I'm too junior to mentor anyone, but the person that gave me this advice actually pointed out to me that there's always someone that coming after me, and I've always something to share with others, even if it's a peer. And then also in the process, you learn so much about yourself by mentoring others.
Yeah, and speaking of mentoring others, STEM Nation, if the career that Stephanie is doing, chemical engineering and electrical engineering, if that's of interest to you, go to the show notes, click on her link. It'll take you to LinkedIn. Connect with her and say, hey, I heard you on STEM on Fire. I'm sure Stephanie would be happy to help out.
Yes, definitely.
And a personal habit that contributes to your success.
I would say that I do self-reflection a lot, but I guess over the last couple of years, I've learned to not turn that into self-doubts. Make sure that when you're reflecting both on your success as well as areas that you didn't work so well. It helps you to to kind of clear your head and really know, okay, this is the area that I have to focus on, and or this is the area that I can actually help others with because I'm pretty good at it. So self-reflection, I would say.
Yep, and don't focus on the negative, focus on the positives. And a favorite internet resource or phone app, and why?
Oh, this one's hard. There's so many. I actually am an Audible user. I love it. I turn it on when I'm driving. I think it's a good it's a good way to get more reading done. Again, going back to the time management piece, you just have to squeeze in time for just learning.
And since you are an Audible fan, but you have to pick one book that you would recommend.
Educated by Tara Westover. It's a book that I read last year, and I kept telling people to read it because I think it gives a lot of perspective on determination and really setting your goal and going after it, even though your circumstances may not be easy or helping you. I think that's a great book.
All right, Stephanie. And you provided tons of value, but we're going to ask for one more. Could you provide a parting piece of guidance for STEM Nation, and then we will say goodbye?
There is a quote that Mark Twain said that if you find a job you enjoy doing, you would never have to work a day in your life. I think it's a very true statement. The part I would say that not to focus on isn't that you would never work a day, but to really kind of give yourself this opportunity to be honest with yourself, what kind of jobs, the nature of it or the topics of it, and also the environment that you'll be working in. I think those are key parameters that you want to be honest with yourself and finding that's the key to finding an ideal job. And if you like your job, working really isn't, too hard.
I agree with that, Stephanie. And with that, we will say goodbye.
Goodbye, everyone.
Thanks, Stephanie. I hope you enjoyed that chat today with Stephanie. Head over to STEMonfire.com, subscribe to the email list to keep up the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player and share it with a friend. Tune in next week we talk with Zoe, who works in the field of computer science. Until next time, I hope this chat has helped ignite your